October 12, 2025. 8 days have passed without any fresh official word on the interstellar traveler 3EI Atlas, which has been drifting by our sun and leaking hints of extraterrestrial makeup. No sharp images, no direct explanations, just a neatly wrapped tale of a comet with an official seal. But could that really be the case? Gaps in the account keep expanding. That's precisely why, this evening, we're stripping away the layers of the story and posing the question on everyone's mind, though few dare voice it. Does the established version hold up as fact, or are deeper secrets unfolding offstage? Sticking to our fresh multi-segment approach, the disclosures grow even more ominous ahead. We'll expose the wandering black hole sneaking through our Milky Way undetected, a stealthy hunter that might shatter our assumptions about safety in the cosmos. We'll tackle the massive gash ripping across the sun at this very moment, one capable of throwing more than just our atmosphere into chaos. Next comes the final timer. Experts alerting us that the universe could implode in a big crunch. And the schedule is alarmingly tighter than you'd guess. On top of that, a steady downpour of satellites is plummeting back to our planet daily. 1 or 2 each day, without fail. So why isn't this sparking louder conversations? If these enigmas grip you like they do me, smash that like button and subscribe to stay caught up on every development as it happens live. Leave a comment noting your location, the local time, and if you think we're hearing the complete story on these game-changing finds. To boost this community, spread the word about this video on X, Facebook, Reddit, or your private chats. It's folks like you who let us pursue tales this gripping. Thanks for supporting the hunt. Section 1. The entry that sparks endless debate. Back on July 1st, 2025, an entity showed up, not originating from our star, but emerging from the vast interstellar void, and it instantly sparked suspicion. Chances are you missed the news. So did most folks. Yet in the hushed halls of astronomy labs and observatories dotted worldwide, researchers started firing off secure emails, arranging urgent video meets, and poring over readings that defied all logic. They labeled it 3EI Atlas, cataloged as C2025A01. The Atlas telescope in Chile caught the first glimpse. It appeared as a dim blur shifting amid the fixed stars, following a path that screamed impossibility. This marked the third verified interstellar visitor humans had ever spotted, coming after the notorious Oumuamua in 2017 and Comet Borisov in 2019. Recall Oumuamua? That elongated enigma that sped up beyond what gravity could account for, that skipped the usual comet venting and slipped away into the starry expanse before we nailed down details. Atlas stood apart, or perhaps it mirrored the others. Consensus proved elusive. The path calculations painted a straightforward picture. This thing followed a hyperbolic orbit, unbound to our solar system. It hailed from some remote corner of the galaxy and would soon vanish again into the void separating stellar systems. Its approach velocity hit around 60 kilometers per second, or roughly 130,000 miles per hour if you like your space speeds in everyday measures. That's blazing. Quicker than any craft we've built. Quicker than the sun's breeze. Swift enough that, when you rewind the orbit, it leads to a sky zone devoid of any star that could have launched it. The body will hit perihelion, its nearest solar pass, on October 30th, 2025, coming within about 1. For astronomical units of the sun. To put it in perspective, 1 AU equals the Earth-Sun gap. Thus, Atlas will dip inside Mars' route, but stay well clear of our planet's lane. Earth's minimal distance, roughly 1.8 AUs. Distant enough to dismiss any wild impact fears from even the most fretful observers. This bore no resemblance to melancholia or don't look up. Any threat, if one existed, lay beyond mere impact. Yet oddities began stacking like clues in a detective's file. Size guesses kicked things off. Early figures pegged Atlas at tens of kilometers wide, dwarfing its interstellar kin. Rival assessments clashed sharply, proposing a tinier form but with bizarre shine. Such variants felt off. Today's telescopes excel at gauging distant boulders. When sizes swing by tenfold or beyond, the culprit's skin or form must be baffling our gear in unnatural ways for a basic comet. Then spectral analyses dropped, and they baffled completely. Typical comets, as they heat nearing the sun, starts to trigger the release of gases from comet nuclei, vaporizing into stunning narratives that span millions of kilometers throughout the solar system. But Atlas defied that typical pattern. Spectral examinations revealed carbon dioxide overwhelming the emissions, with water vapor hardly detectable. Even more peculiar, certain readings picked up elevated levels of nickel in the outflow, a substance that shouldn't show up in such amounts from a standard comet's venting. One could expect experts in the field to be proclaiming this discovery far and wide. Picture urgent media briefings, hastily submitted studies, observatories globally redirecting their focus to monitor this odd interloper. Bits of that occurred, no doubt, yet the overall reaction remained subdued, tentative, laced with caveats and possibilities. Plenty of researchers openly regarded Atlas as merely an unusual yet organic comet, a deviation in the lineup, but nothing truly baffling at its core. Comets vary widely, they pointed out. Every star system boasts its unique makeup. It's unrealistic to assume every incoming body will align with the makeup of items originating from our local stellar turf. Still, murmurs circulated in the remarks under draft manuscripts, during subdued chats at gatherings, and in private messaging groups where scientists expressed themselves more candidly than in formal publications. A few were voicing the idea that hovers on the fringes of acceptability in contemporary stargazing. Suppose Atlas wasn't wholly organic? Suppose we're observing an artificial construct, a manufactured device, an intentional dispatch? Terms like probe started surfacing, often tucked into if-then scenarios and what-ifs. The notion of alien was uttered even softer, typically paired with an uneasy chuckle, a cue that the utterer realized they were venturing into risky territory. Professional paths have suffered from embracing such ideas too earnestly. Credibility has been earned by debunking them, but the data paid no heed to prestige. The composition ignored job security. And with October looming, as Atlas closed in and our instruments captured additional illumination from its exterior, the oddities refused to settle into tidy rationales. If anything, they proliferated. So, that's our situation. A visitor from beyond our star system is currently traversing our celestial patch. While you're taking in this account, it's exhibiting traits that don't align neatly with our frameworks for natural entities. The information at hand remains partial, fragmented, occasionally at odds. And the organizations we rely on to interpret such phenomena are responding with deliberate, restrained phrasing that could stem from prudent science or perhaps something more guarded. The issue isn't Atlas's peculiarity. Consensus holds that it is peculiar. The real puzzle is the nature of that peculiarity and who holds the authority to define it. Coming up, we'll explore the rhythms, the rotations, and the dilemma that torments a particular breed of researcher during sleepless nights. Is it transmitting or merely drifting aimlessly? Part 2. Rhythms amid the shadows, transmission or rotation. Illumination narrates tales if you're versed in deciphering it. Each particle of light hitting our scopes holds details embedded in its color spectrum, its wave alignment, its arrival sequence. When stargazers examine something like Atlas, they go beyond viewing a mere speck overhead. They're scrutinizing fluctuations in that speck's intensity across time, building a luminosity profile, a chart plotting glow against hours, days, and months. Typical comets yield disorganized, erratic luminosity profiles. They spin haphazardly across the cosmos, their spins thrown off by irregular venting pressures. Their exteriors riddled with craters and uneven. The intensity shifts we observe boil down to randomness, erratic swings as varied terrain faces the sunlight differently. It's like visual static, foreseeable solely in its chaos. Atlas bucked this trend, or it partially did and partially didn't, which could feel even more disquieting. Its luminosity profile revealed shifts that were remarkably consistent. Intensity alterations that cycled on specific intervals, hinting at an organized form instead of wild spinning. Parts of the dataset exhibited repeating cycles that had experts huddling over screens, verifying their setups, questioning if their eyes, or instruments, were deceiving them. The precise jargon is photometric periodicity, and it's precisely the sort of thing you'd anticipate from a vessel methodically turning to manage its alignment, or from a scout crafted to beam signals across the universe, or from various constructed mechanisms needing exact rotational management. To be balanced, It's also feasible from a native form with an atypical yet understandable contour. Maybe a paired binary, two lobes linked by a slim bridge, revolving steadily. But then the alignment readings came in, and the situation escalated in oddity. Alignment gauges the orientation of light's oscillations as they journey through the cosmos. Oriented objects exhibit certain alignments. Light that's unpolarized oscillates randomly in every direction at right angles to its trajectory. In contrast, polarized light oscillates within defined orientations, and the extent plus orientation of that polarization reveal details about the characteristics of the surface that bounced or dispersed that light. Irregular surfaces tend to strip away polarization. Sleek ones, however, can generate pronounced polarization patterns. Particular configurations can lead to negative polarization, in which the polarization reverses counter to typical expectations. For Atlas, observations revealed intense negative polarization at specific viewing angles, levels that stretched beyond predictions from established models for familiar natural materials. One study labeled it as unusual polarization that's at odds with conventional comet dust frameworks. Another referred to it as geometric albedo traits implying structured, non-uniform surface features. These represent the cautious, nuanced remarks experts offer when encountering data that defies norms, though they're hesitant to speculate openly on its true nature. Picture a lighthouse. Its light sweeps over the sea in steady cycles, delivering a rhythmic signal to anyone watching. Now envision that structure spinning wildly across the void at 60 kilometers per second. Rather than emitting a steady beam, it's bouncing back solar rays in sequences that seem too patterned to be chance, yet not patterned sufficiently to confirm artificial origins. That's roughly the scenario we're examining. It could serve as a signal, or it might simply be the cosmos's most awkwardly contoured stone. The measurements of non-gravitational motion introduced further complexity to the enigma. By monitoring an object's trajectory with high accuracy, slight divergences from a purely gravitational route become apparent. Comets routinely display such shifts. The release of gases functions like a faint thruster, nudging the comet off its predicted path based on the spots where vapors escape from its body. In typical comets, these influences balance out over time through symmetry. But for Atlas, the non-gravitational motion patterns prove challenging to account for using routine gas emission theories. A few experts suggested it was a dust-laden comet, a grimy boulder ejecting mostly solid debris instead of vapors, generating thrust via sunlight's push on those grains rather than gaseous outflows. This idea addressed certain chemical peculiarities and some motion irregularities. It stood as a solid theory, a balanced middle ground between an oddball comet and a potential extraterrestrial device. It didn't resolve all issues, but it covered sufficient ground to gain credibility. Perhaps that's precisely what it amounted to. Perhaps Atlas merely inhabited an underexplored corner of the spectrum for celestial wanderers, signaling that our theories required tweaking, not overhauling. The cosmos owes us no clarity. It remains unmoved by our bafflement. It persists, unconcerned with our cravings for tidy classifications and straightforward answers. Yet what persistently troubled the scientists poring over those brightness variations deep into the evening was this. If you aimed to dispatch a spacecraft to a distant solar system, if you sought to make it noticeable, yet subtly non-mechanical, if you intended to straddle the divide between conspicuous and innocuous stone, how would you craft it? You'd likely fashion an entity that appeared largely organic, one that could reasonably pass as a comet or asteroid. But it would incorporate subtle geometric consistency to intrigue sharp-eyed analysts. You'd build in vagueness. You'd incorporate plausible excuses. You'd aim for viewers to debate endlessly over their observations. And that's precisely the outcome we observed. The radio observers detected zilch. Naturally, no obvious repeating pulses, no encoded transmissions, no signals broadcasting across the radio bands in unmistakably engineered fashions. But lack of proof doesn't prove lack. Especially given our scans cover only select wavelengths. Our dishes aim at restricted sectors, and the object's rapid pace would distort any emissions via Doppler effects, rendering them hard to identify. Thus, we're stuck with uncertainties, patterns that could signal intent or mere rotation. compositions that might hint at otherworldly origins or stem from an unfamiliar star-forming environment, motions that could stem from venting or alternative causes. Each piece of evidence supports dual or triple readings, and selecting among them demands data we lack or a bold assumption one way or the other. How does this stack up against other cosmic intruders we've spotted? What insights do past anomalies offer about bodies that skirt the edges of expectation? That's the direction we explore next, delving into Oumuamua legacy and the lessons it imparted. It teaches us about gaining a clear perspective. In the third installment, The Enigma of Oumuamua. On October 19, 2017, the Pan-STARRS telescope in Hawaii detected an anomaly traversing the inner solar system along an improbable path. Initially, experts figured it was just an asteroid or comet originating from our own Kuiper belt, nudged closer by some gravitational nudge. Yet, as fresh data poured in over the following days, the orbital models pointed to an unsettling reality. Dubbed Oumuamua, meaning scout or messenger in Hawaiian, this interloper had journeyed from beyond our stellar neighborhood. For the first time ever, humanity had verified an extraterrestrial body slicing through our system. The inaugural instance we could confidently declare witnessing a guest from a distant star. And it was downright odd. As Oumuamua swung away from the sun, it picked up speed with a subtle yet detectable boost that gravity couldn't fully account for. There was no comet-like tail, no venting gases, no obvious traces of the icy volatiles that ought to vaporize under solar heat. From the fluctuations in its brightness during its spin, its form appeared strikingly slim, potentially tenfold longer than broad. A profile almost unheard of in typical asteroids or comets. Certain analyses stretched that slenderness to extremes, hinting at a needle-like or cigar-shaped structure that upended standard origin theories. The research world fired back with a flurry of studies offering earthly rationales. Perhaps it was a shard from a world ripped apart by tidal stresses, or made of exotic stuff that didn't vent in detectable ways. Or the speed-up stemmed from invisible hydrogen ice sublimation, providing just enough propulsion without showy signs. Perhaps, or so the theories went, each one patching a hole while poking new ones. Every idea demanded exceptions, plausible yet rare scenarios, handy but unproven tweaks. Then Avi Loeb weighed in. As head of Harvard's astronomy department, Loeb boasted a stellar track record and ample clout. Yet he openly floated the notion that Oumuamua could be engineered. He speculated it might be a light sail, a gossamer mirror propelled by stellar radiation, either a relic of extraterrestrial tech adrift in the void or, bolder still, a deliberate emissary from an alien society. The academic backlash was nothing short of scorching. Critics branded Loeb a showman, tarnishing the field's image, ditching evidence-based inquiry for headlines. The outcry was raw and ferocious, sparking its own puzzles. Why did whispers of alien artifacts trigger such knee-jerk defenses? 2 years on, in August 2019, a second wanderer appeared, labeled 2I/Borisov. This one acted the part of a classic comet, spewing gases predictably, sporting a clear tail, and matching the makeup of our local icy drifters. The astronomy crowd let out a unified exhale. There, they implied, extraterrestrials are mundane after all. Oumuamua was quirky, sure, but sortable. Back to business as usual. Except 3I/Atlas refuses to let us slide into routine. In key respects, Atlas echoes Oumuamua more than it mirrors Borisov. Each exhibits quirky acceleration defying basic orbital math. Each boasts traits, chemical or structural, that don't neatly slot into our classifications. Each straddles the line between icy wanderer and stony chunk, belonging fully to neither. Yet Atlas could dwarf Oumuamua if the scale projections hold true. It unleashes that peculiar carbon dioxide-heavy, venting unseen in its forerunners. And those nickel traces, the wild polarization, the rhythmic light dips, they thrust it into uncharted ground. Ground where our tidy comparisons crumble. Where Atlas truly diverges from its kin is in the uproar it stirs. For Oumuamua, astonishment reigned. We grappled with the sights, open to diverse angles. For Borisov, comfort returned. We rushed to box it with the familiar. But for Atlas, it feels like the experts have prejudged the narrative before the full picture emerges. Post-Oumuamua fallout, amid the barbs and rebuttals, after seeing a prominent peer crucified for probing thorny ideas, plenty of astronomers appear to have subconsciously vowed caution to spotlight mundane causes, downplay oddities. This amounts to overcompensation. Get singed by a blazing burner, and you might shy from every appliance, even cold ones. Endure a field scorch from bold ET talk, and it could breed excessive scorn for any clue veering that way. And yet, we often brush aside compelling evidence just the same. The lingering sentiment from the Oumuamua controversy could be shaping our current take on Atlas, fostering a preference for standard theories that's every bit as unrigorous as jumping to the conclusion that anything unusual has to be man-made. Lowe has taken it upon himself to document these oddities, contending that our ways of making sense of things are inherently slanted against spotting signs of advanced tech. He highlights the fact that humanity has already proven capable of building interstellar craft, sending out probes past our solar system for years now. Suggesting that some other society might pull off the same feat isn't far-fetched at all. It's straight out of the mediocrity principle. The simple idea that we're nothing unique, and whatever unfolded on Earth likely played out on other worlds as well. If the proof for everyday causes falls short, if we're stretching to dream up ever more bizarre scenarios just to stick with familiar ideas, perhaps we're overlooking the most straightforward answer, one that's tough to swallow only because of its deeper ramifications. The backdrop of history plays a key role here. Over the ages in astronomy, we've bumped into celestial bodies that appeared bizarre, resisted easy answers, and sparked talk of non-natural sources. When pulsars were first spotted, scientists half-jokingly dubbed them LGMs, little green men, owing to their eerily rhythmic radio signals. Quasars upended our grasp on energy output from compact regions of space. Fast radio bursts remain without a fully convincing origin story. Time and again, we've uncovered natural processes behind these puzzles, processes that turned out to be wilder and more captivating than any engineered alternatives. But the key point is this. Our success in pinning natural causes on past enigmas doesn't mean every mystery will yield one. That's the trap of inductive reasoning, figuring that since something held true before, it'll hold forever. Someday, should we stumble upon genuine traces of alien engineering, they'll strike us as outlandish at first. They'll clash with our starting assumptions. They'll ignite debates just like this one. And if we've conditioned ourselves to reject tech-based ideas outright, to scramble for some forced natural fix every time, we could squander humanity's greatest breakthrough, all to dodge the unease of being boldly correct instead of cozily mistaken. So what about Atlas? It's drifting erratically across the void, caught between solid proof and guesswork, glimpsed by tools that catch mere slivers of reality without the full view. This leads to what might be the story's most unsettling feature: the absent information, the photos that ought to be out there but aren't, the holes in the official accounts that could be harmless oversights or something more deliberate. Let's dig into what's gone unseen and why that absence could outweigh the glimpses we've got. Part 4. The issue of lost data. Today's astronomy thrives on floods of information. We've got scopes in space, gear on Mars, stations dotting every landmass. When a noteworthy visitor swings into our inner system, a slew of devices can train on it, snapping pics in various spectra to assemble a full profile of the intruder. At least, that's the plan. Reality, especially regarding Atlas, diverged sharply. The European Space Agency shared a shot from the CASSIS instrument on the ExoMars Trace Gas Orbiter. CASSIS, built for sharp scans of Mars's terrain, got redirected to snap Atlas amid its nearer pass by the red planet. The result? A dim speck sliding past starry backdrops. A blur hardly clearer than static. A snap that verified Atlas's presence and position per the trajectory models, yet divulged zilch on its makeup. For something pegged at dozens of kilometers wide, cruising into the sight line of a top-tier imager, the vagueness was maddening. Maybe Atlas measured way tinier than projections, or it absorbed light strangely, or the aim fell short, or a mix of issues teamed up to deliver the most useless view imaginable. Next up, the Perseverance rover, NASA's premier red planet explorer, fitted with sky-scanning cams that track twisters and vapor trails, spotted Atlas on October 4th as it crossed the Martian heavens. What turned up in that shot? A dash of brightness, a luminous trail aligning with a body transiting the stellar field. Timing and trajectory syncing with forecasts for Atlas. Once more, validation sans insight. It placed Atlas right on target, on course as expected, but shed no light on its true identity. Such visuals did surface, getting announced, featured in announcements and news blurbs. Scientific publications provided scant details. Perhaps that's acceptable. Perhaps these tools simply weren't built or aimed in ways that could deliver superior information. Yet this is where things turn peculiar. Additional devices ought to have recorded visuals, sharper ones, and those haven't surfaced. The Mars Reconnaissance Orbiter hosts HiRISE, the high-resolution imaging science experiment that can discern Martian terrain details as fine as 1 meter in width. Upon an interstellar visitor approaching fairly close, one would anticipate HiRISE being assigned to snap photos, several shots, following the intruder over multiple passes to compile a thorough collection. So where are those visuals? The MAVEN probe, focused on Mars's upper layers of air, features optical tools that could have added sightings. What's happened to that information? The Mars Odyssey satellite, active since 2001, includes thermal imaging features that could spot warmth traces or evaluate the visitor's exterior heat. Has any of that been made public? When authorities do provide reasons, if they bother at all, they cite detection thresholds, timetable clashes, equipment limitations. HiRISE targets ground landscapes, not speedy sky wanderers. MAVEN's gear suits air studies, not boulder pursuits. The workflow for handling data demands time, fine-tuning, and checks prior to distribution. And incidentally, the federal closure in early 2025 disrupted many NASA activities, generating a pileup of analysis jobs that's ongoing. Such accounts make sense. They're logical. They could well be spot on. But they arise amid a backdrop where missing info breeds room for rival interpretations. When folks anticipate viewing certain things and come up empty, when organizations known for meticulous logging abruptly show holes in their files, doubt rushes to occupy the void. There's a lengthy record of accusations that cosmic agencies have altered, postponed, or suppressed odd visuals. The famed face on Mars, revealed as a hill molded by wear and light play, but first shared without clear context, conditioned a cohort to doubt NASA's photo distributions. Countless fringe ideas insist that shots from moon voyages, rover explorations, and satellite scans have been cleaned or softened to erase signs of constructions, relics, or further oddities. The bulk of these ideas are baseless, mere chance patterns mistaken for intent, spotting order in chaos. Yet the prevalence of mostly baseless ideas doesn't render all of them invalid, nor does it guarantee that bodies always share challenging info openly. The European Space Agency enforces a 6-month hold on most unprocessed data. Visuals and readings get gathered, refined in-house, employed by research groups, and solely afterward posted to open repositories. This routine aims to allow experts initial review before broader examination. It's valid from a research standpoint and essential in practice. It also implies that precise shots of Atlas could be stored on ESA systems at present. Shots unavailable to the masses until mid-2026. Shots potentially resolving the uncertainties we're now grappling with in this info void. This fosters what's termed the information gap phenomenon, when society learns that records should be out there but remains barred from them. When the divide between captured events and disclosed material widens enough to stand out, stories surge forward to occupy the territory. Certain tales lean toward fear, others toward plots. Others suggest concealments, hidden insights, and official deceit. And others, perhaps some hold truth, or at least partial truth, since lacking proof truly signals a shortfall when you anticipated that proof would appear. Reflect on the motivators involved. Should Atlas prove merely an unusual comet, promptly sharing every bit of obtainable info poses minimal hazard and boosts knowledge growth? Should Atlas represent something vaguer, perhaps engineered or displaying traits beyond our grasp, disseminating such info stirs issues. It draws fierce examination. It sparks inquiries the body may lack readiness to address. It could expose strengths or weaknesses in our tools that parties might wish concealed. It endangers societal alarm or bewilderment if unveiled sans fitting background. Nothing here confirms concealment, yet it shows that credible reasons for picky disclosure persist, and the disparity between gathered observations and public shares exceeds what standard research prudence would justify. Society is urged to believe that the entities probing Atlas deliver the complete view, even as they're informed that vast portions of that view remain unavailable for inspection for months or years. It's a tough challenge, especially considering what's on the line. This leads straight to the core issue driving our whole inquiry. Why should it matter at all? If Atlas turns out to be a natural phenomenon, we pick up some fascinating insights into cosmic chemistry and carry on. But if it's man-made, or rather, alien-made, that would rank as the most groundbreaking discovery in the annals of humanity. Yet beyond these stark scenarios, the true implications lie in how we make sense of these puzzling phenomena. What are we truly contesting when we argue over whether Atlas is merely a comet or something extraordinary? Let's delve into the nature of belief and the price we pay for it. Part 5. Belief, Skepticism, and the Risks Involved. Consider this straightforward query. Why does it count if Atlas is nothing but a comet or potentially far greater? How does that alter your daily existence, your aspirations, or your sense of position amid the stars? Should the conclusion tilt toward the natural? If all those irregularities boiled down to routine chemical and physical processes, we'd open a precious glimpse into the makeup of a distant solar system. We'd discover that worlds parsecs away can yield comets bearing chemical profiles unlike our own, that the processes shaping stars show greater variation than anticipated, that the cosmos brims with diversity we're just starting to map out. It's a boon to science, a spark for the mind, yet another piece in our growing puzzle of interstellar reactions. We draft studies, tweak theories, and shift focus to the subsequent enigma. On the flip side, if Atlas proves to be constructed, if we're truly gazing upon signs of alien engineering, the world flips upside down. This is an exaggeration. Verifying the presence of intelligent life beyond Earth, confirming that societies can emerge and endure sufficiently to dispatch interstellar craft, affirming solitude's end in the universe. That epiphany would mark the pivot point of human chronicles, dividing eras before and after. Our notions of purpose, destiny, and duties to the wider expanse would all reshape in an instant. But these represent the tidy endpoints, the clear-cut paths. The thornier puzzle emerges in the gray zone of doubt, the space we occupy right now. Because at this moment, we remain in the dark about Atlas's identity. Data streams pull us toward conflicting interpretations. Organizations issue statements we can't scrutinize on our own. Information voids could stem from mere oversight or deliberate secrecy. And we, the general populace, face pressure to form opinions sans complete proof. Here, the mental dimensions come into play. How our kind reacts to the prospect of initial encounter, or even vague suggestions of it, exposes our essence as a collective. Do we greet the unfamiliar with wonder or dread? Do we press for openness from authorities or yield to their expertise? Do we permit ourselves to grapple with unsettling ideas, or do we hunker down in reassuring absolutes? The Atlas saga, no matter its final resolution, serves as a gauge of our society's readiness. Institutions face pressures too. Agencies exploring space rely on taxpayer dollars and governmental favor. Their resources hinge on upholding trust, on projecting rigor and empiricism over guesswork and hype. Should outfits like NASA or ESA declare they've spotted alien tech only to be disproven, the blow to their standing would be severe. Appropriations might shrink. Directors could get ousted. Upcoming ventures might get axed. The system nudges them toward restraint, toward ironclad assurance, toward declarations backed beyond reproach. That's reasonable. It's relatable. Yet it fosters a slant that might lead us to overlook or brush off real oddities, since admitting them invites career hazards. Add to that the peril of confirmation bias, the habit of twisting fresh findings to fit preconceived notions. If you're hoping Atlas is an extraterrestrial scout, you'll spotlight the quirks and minimize the standard accounts. Each quirky reading morphs into backing for your theory. Each hole in the shared info signals a conspiracy. You're not fabricating or acting irrationally on purpose. You're simply mortal, sifting the world via the filter of your settled views and wishes. But the flip side looms equally: rejection bias, the impulse to spurn jarring options no matter the proof. If you're locked into seeing Atlas as purely natural, you'll highlight the everyday rationales and sideline the peculiarities. Each quirky reading shrinks to a trivial issue, not a profound riddle. Each info gap reads as harmless lag, not shady suppression. You're not deceiving anyone. You're merely shielding from the unease of worldview upheaval, from the disorientation of seeing core cosmic tenets upended. These pitfalls snare us both ways. They steer clear of honesty. The real test is if we can juggle rival scenarios at once, weighing them by data over inclination, adjusting, embracing evolving perspectives as fresh evidence emerges, instead of rigidly holding onto early stances no matter what the cosmos reveals. This ties into a more profound philosophical inquiry. Does faith in alien probes represent a contemporary legend? A substitute in our tech-driven era for deities and celestial messengers? A reflection of our aspirations and anxieties projected onto the stars? Or perhaps a logical deduction drawn from the evidence at hand? Employing Bayesian logic, which posits that considering the vast expanse and antiquity of the universe, the multitude of worlds that might support life, and humanity's own emergence as evidence that sentience can develop, the probabilities tilt toward the presence of other societies, and possibly their dispatch of scouts across the emptiness. The resolution remains elusive. Each viewpoint carries weight. Both sides can summon compelling arguments and reasoning to support them. What stands out is the deep significance of the debate, extending beyond our analysis of Atlas to our very self-perception. Are we isolated in existence? If not, what implications does encounter hold? Should we be encountering, monitored, or merely grazed by wanderers from distant realms? What duties does that impose upon us? These queries transcend mere intellectual pursuits. They pose urgent dilemmas with tangible effects on resource distribution, long-term strategies, and our vision of humankind's place in the grand stellar narrative. And here's the harsh reality. We're shaping these choices, cultivating these convictions, and grappling with these issues amid partial knowledge. The complete dataset resides elsewhere. Photographs that might clarify uncertainties. Spectral analyses capable of validating or disproving theories. Viewing logs that would allow unclouded examination of Atlas, free from the haze of curated disclosures and bureaucratic restraint. Yet that information eludes us. We're urged to have faith, to yield judgment, to endorse the notion that experts with superior insight are wisely deciding on disclosures and concealments. Perhaps they are justified. Perhaps the organizations probing Atlas possess solid grounds for their outreach methods. Perhaps their actions are rigorously scientific and morally upright. Still, the inherent framework of this scenario, the imbalance in knowledge, the divide between concealed truths and public revelations, fosters doubt and conjecture. By regarding the populace as immature minds incapable of facing stark realities, it's no wonder that the public suspects' vital secrets are being suppressed. Thus, we're mired in ambiguity. An intruder from a remote sun exhibiting traits that defy our frameworks, captured by tools whose readings remain partially withheld, analyzed by entities harboring intricate agendas. Atlas lingers overhead, both physically and symbolically. A punctuation of interrogation crafted from stone, alloy, or some unknown substance. And we're compelled to form opinions on it, sans the details essential for sound judgment. Yet Atlas isn't the sole enigma unfolding in the heavens these days. Latest findings and emerging astronomical updates could offer background, juxtaposition, or hints for deciphering our celestial guest. In the upcoming segment, we pivot to current space developments, to oddities and occurrences that could connect, align by chance, or signify more. For occasionally, unraveling one puzzle demands surveying the array of riddles encircling it. At times, the design emerges only upon retreating to behold the entire expanse. Section 6. An orphan black hole. Picture the densest entity imaginable. A neutron star? Insufficient density. A galaxy's nucleus? Too fixed. Envision now an object packing the heft of multiple suns into a space tinier than an urban sprawl. distorting space-time to such an extreme that no entity, not even photons, can break free from its pull beyond the event horizon. That's a black hole in your mind. Now release it to roam. Sever its ties to any galaxy, star cluster, or binding force. Dispatch it meandering across the interstellar gulfs. A stellar hunter prowling the shadows. In 2025, stargazers verified sightings of what's dubbed a wandering black hole. A black hole of stellar scale, unbound to any clear gravitational tether, gliding through our Milky Way like a spectral vessel navigating unseen harbors. This isn't wholly unexpected in principle. Such voids arise from the implosion of hefty stars, and the orbital mechanics dictating star paths can sporadically eject a black hole from its origin group, launching it into solitary traversal of the cosmos. The astonishment lies in spotting it. Black holes are notoriously elusive, manifesting solely via their tidal influences on adjacent substances or the emissions from infalling debris. A nomadic black hole lacking a stellar partner, sand surrounding disk of gathering matter, without handy fuel to devour and glow, proves nearly impossible to spot via standard methods. The identification stemmed from gravitational microlensing. A method leveraging Einstein's theory of general gravitational microlensing occurs when a hefty body glides between Earth and a distant star, warping the starlight through its immense pull and producing a fleeting surge in brightness before it fades as the positions shift. Through precise tracking of these luminosity shifts, scientists can deduce the intruder's size and speed. Here, the microlensing pattern pointed to a shadowy, dense entity boasting a few times the Sun's mass, traversing the Milky Way's disk at speeds typical of a dead star rather than an active one. This discovery mattered deeply, as it backed up long-held theories and opened a window to spot a class of bodies predicted to abound, yet seldom glimpsed. Simulations indicate that the galaxy hosts hundreds of millions of black holes around stellar masses, leftovers from long-ago stellar explosions, mostly hidden from view and only betrayable when they align just right with the star we're watching. Our cosmic home teems with unseen traps of gravity, ravenous voids in the fabric of space-time ready to swallow any unlucky traveler past their boundaries. Turning to Atlas, the question arises, might a free-floating black hole have nudged the path of these spacefarers from beyond? Could such a gravitational brush account for the odd path details we're noting? On the surface, it feels reasonable. These cosmic titans dominate with their pull. Even a far-off brush could veer a body off course, perhaps accounting for the route that delivered Atlas to our neighborhood from its unknown cradle. Yet the calculations fall short. We grasp gravity's dance intimately, refined through rigorous checks. To bend Atlas's course markedly without snaring it or boosting its pace further demands an extraordinarily precise alignment, navigating a cosmic pinhead over vast light-year spans. Feasible, sure, since physics allows it. Probable? Hardly. The cosmos offers plenty of routine jolts to paths without needing lone black holes. Still, there's a poetic echo in these twin oddities surfacing together in our sights. A homeless void and an origin-less wanderer, both adrift in the void, both challenging our neat labels. They underscore how the Milky Way pulses with unrest, teeming with stray threats and enigmas beyond the neat sketches in astronomy books. We picture the void as vast emptiness dotted by matter and glow. Truth is grimmer. The expanse brims with unseen masses cruising shadows, relics of star graves drifting amid the lights we track. Spotting these nomad voids also stirs uneasy thoughts on other drifters lurking beyond. If star corpses can get flung from their origins, why not shattered worlds? Or free agents never tied by gravity? Or items set on deliberate courses, not mere chance tugs? The tally of interstar voids stays largely blank. We catch only the luminous or reflective arrivals. The rest, the everyday dark stuff, not the universe-scale kind, stays cloaked until it drifts near our gear for a peek. This ties into a broader thread in our probe, the realization that the void defies our vision of calm, foreseeable order. The neat orbital flows we presumed, with all circling central poles, get tangled by outliers and nomads flouting the rules. If we're off on voids, on the count and kind of stargap roamers, what other assumptions crumble? The moment feels pointed, too. It's 2025, and we're charting a quirky space intruder across our system while verifying lone black holes prowling the galaxy. These aren't linked by default. The field buzzes with fresh insights nonstop. But the pileup of quirks, the bunching of weird data in a tight time frame, tempts our brains to hunt hidden ties. Linkage doesn't mean cause, yet it can hint at buried patterns we haven't grasped. And voids aren't the sole cosmic scar pulling focus now. As we monitor galactic drifters, our sun has sprung a wound. This interference impacts all the phenomena we're attempting to scrutinize. Now, let's shift focus to our star and a potential gap that could be clouding our view of reality itself. Chapter 7. The enormous gash on the sun. The sun doesn't present a flawless orb. We often picture it as an ideal ball of nuclear fusion and radiance, steady and reliable, the stellar motor driving our solar neighborhood. Yet, what solar observatories uncover is far more turbulent. The sun's exterior churns with boiling convection zones and twisted magnetic fields. Dark sunspots emerge and vanish. Vast prominences loop tens of thousands of kilometers into the void. And from time to time, the sun develops a rift. Coronal holes live up to their name. They're openings in the sun's outermost layer where magnetic lines fail to curve back down, but instead surge straight out toward the cosmos. These aren't literal voids devoid of substance, but areas where the plasma runs cooler and sparser compared to the nearby corona, showing up as shadowy spots in extreme ultraviolet views. Crucially, they serve as launch points for the solar wind, which races away unchecked at velocities reaching 800 kilometers per second, hauling along energized particles and magnetic influences far across the solar realm. In October 2025, instruments spotted a gigantic coronal hole pointed right at our planet, one of the biggest spotted lately. It spanned a large portion of the sun's facing side, a shadowy blemish amid the roiling glow, resembling an unhealing stellar injury. Experts warned that intense solar wind bursts would hit Earth soon, possibly sparking magnetic disturbances in our magnetosphere, hampering satellite functions, sparking northern lights at odd southern spots, and overall turning the space around our world into a wilder electromagnetic mess than usual. For everyday folks, these coronal holes mainly catch interest because they spark stunning auroras. The rush of charged matter from the sun clashes with our planet's protective field and air layers, energizing particles to glow and draping the heavens in veils of emerald, crimson, and violet. It's a breathtaking spectacle among nature's grandest light shows, pulling in shutterbugs and sightseers to polar regions whenever big solar events loom. But for stargazers aiming to capture sharp data on dim celestial bodies, these solar outbursts spell disaster. The barrage of particles swamps radio signals, generating static that overwhelms subtle transmissions. Shifts in magnetic patterns can throw off satellite maneuvers, blurring snapshots from space-based scopes. Even Earthbound visual instruments suffer as heightened ionization high-up warps incoming starlight. Whenever the sun sports such a gash and hurls plasma our way, our capacity for crisp cosmic glimpses fades. Think about the schedule here. The comet or asteroid known as Atlas hit its perihelion, its nearest point to the sun, on October 30th, 2025. That was prime time for scopes to snag the sharpest readings, with the body shining brightest, nearest, and easiest to study. And right then, a huge coronal hole loomed toward us, when solar winds peaked and electromagnetic havoc reigned. Mere chance? Most likely. The sun's rhythms run on their own, separate from any wandering rocks or icy visitors. These holes form from magnetic forces we can't fully steer or foresee. The clash was just rotten timing, an unlucky sync of study slots and stellar moods. Or could it be more? This is where caution enters our storytelling. It's tempting to spot designs in chaos, to twist flukes into plots, to suspect the cosmos, or some force inside it, deliberately syncing events to muddy our sight. That's probably not the case. Still, the fallout persists no matter the reason. Right in the key stretch for probing Atlas up close, our gear labored under handicap, battling stellar clutter for every scrap of info. Faint hints, odd quirks, tiny traits that could clarify the object's secrets. Those became tougher to detect, simpler to overlook, quicker to vanish in the interference. The imagery proves compelling. A tear in our sun, a scar on the life giver, throwing up a foggy veil just when we craved sharp focus. It plays out like a suspense novel script, crafted to amp up the doubt. And perhaps that's exactly what it amounts to. A happenstance that strikes as portentous since we're wired to find intent in the haphazard. Yet it's worth noting that if something sought to traverse a star system unseen and vague, if it aimed to slip by while staying elusive, aligning its path for an era of intense solar turmoil would be the savvy move. Uncertainty poses a real challenge in strategic terms. It could actually work in your favor, with poorer surveillance due to the interference drowning out your traces and the instruments losing their sharpness in following you. That's the tricky part of ambiguity. Once immersed in it, each piece of information lends itself to various readings. The coronal hole might simply be solar weather, the star's natural rhythms playing out as usual. Alternatively, it could serve as camouflage, a disruptive pattern aiding something intent on staying vague. Each view aligns with the evidence at hand. Yet neither can be firmly established or dismissed given what we know. We're back in that fuzzy zone between certainty and guesswork, and the universe's oddities extend beyond solar voids. As we've tracked drifting bodies and our sun leaking charged particles into the void, experts in cosmology have started rethinking the grand conclusion of all existence. Will the cosmos keep growing indefinitely, or is it veering toward implosion? Consider how evolving views on the universe's endpoint could be coloring our take on current oddities. Part 8. The collapse timer begins. The cosmos is swelling outward. All observable galaxies are receding from one another, with the fabric of space expanding akin to the skin of a balloon being pumped up. This stands as verified reality since Edwin Hubble's discoveries in the 1920s. Over years of sharper observations, we've seen the growth speeding up, propelled by dark energy, an enigmatic force in the universe that mimics repulsion on vast scales, forcing everything farther apart at an increasing pace. In the prevailing theory, this outward push endures eternally. Galaxies fading from sight past our observable limits. Stars extinguishing gradually. The whole realm turning frigid, shadowy, desolate, culminating in a thermal demise after trillions and trillions of years. This has long been the accepted outlook, a distant dread that's almost soothing in its remoteness. A conclusion so far off and detached it hardly feels ominous. We've got eons ahead, unimaginable stretches. No matter what befalls humanity, Earth, or our patch of the cosmos, the universe endures for ages. But come 2025, some key studies started challenging that certainty. Fresh looks at dark energy's traits, faint clues in the cosmic microwave background, updated simulations of the expansion's historical shifts, all hinted at a scenario once brushed off as improbable. Suppose dark energy doesn't stay steady? Imagine it fading, evolving, or undergoing a transformation that turns expansion into shrinkage. What if the cosmos's path leads not to thermal fade-out, but to the big crunch, a total gravitational squeeze that drags it all inward again? Galaxies smashing together, space folding in, all substance and force compacted into one spot, mirroring the Big Bang in reverse. These studies were cautious, full of caveats, stressing that proof remained elusive. Eternal growth still held the edge in likelihood. Still, the chance of reversal, previously deemed near impossible, now carried a modest but real weight, perhaps 1%, or 5%, sufficient to make top researchers take note, model it out, and ponder the telltale signs that could validate or debunk the idea. Why link this to our probe into Atlas? Because overarching cosmic tales guide our reading of nearby puzzles. When the universe's long-term path seems fixed and the big picture reliable, strange happenings get fitted into that solid structure. This comet acts peculiar, yet the cosmos holds steady. Thus, the peculiarity fits our current theories somehow. But if the cosmic tale wavers, if its finale shifts, then doubt creeps in everywhere. If we've misjudged the universe's endgame, what other errors lurk? With the foundation wobbling, those oddities might warrant closer scrutiny than before. Plus, there's a mental angle. Tales of doom, forecasts of universal closures, often surge amid societal unease or major upheavals. In plague-ridden, turbulent medieval Europe, end-times visions proliferated. The Cold War spawned visions of atomic fallout and breakdown. Today, amid ecological chaos, volatile politics, and swift tech leaps, cosmic catastrophe stories, both imminent and remote, gain fresh traction. The Big Crunch tale slots right in. It offers a universal reboot, a finale doubling as a fresh start, a squeeze that could spark another Big Bang and fresh cosmos. It carries emotional appeal that thermal death lacks. The latter's merely chaos prevailing, all things gradually unraveling to oblivion. The Crunch suggests intent, renewal, the chance that realms emerge, perish, and emerge anew. It cycles through an endless loop. This is essentially myth wrapped in the garb of equations. And it resonates with a profound aspect of our psyche that craves order and purpose in existence, something more than mere entropy. Thus, when studies emerge proposing that the cosmos could contract instead of stretching out indefinitely, they're not merely delivering arid scientific findings. They're crafting a fresh storyline, an alternative perspective on the universe's ultimate fate. That storyline conditions us to view current occurrences via a specific filter. If the entire cosmos is barreling toward implosion, toward pulling back all the scattered elements, perhaps extraterrestrial travelers like Atlas aren't mere drifters, but elements in a grander design, some celestial ballet beyond our grasp. This is clearly conjecture, of course. The link between cosmic theories and spacefaring bodies is flimsy, to say the least, yet stories don't require airtight logic to hold sway over the mind. Once you embrace the idea of the universe marching toward a core shift, you begin spotting indicators of that shift all around. Each oddity turns into a harbinger. Each puzzle becomes a hint. The lens changes. And so does how you make sense of everything seen through it. Now, the awkward reality. Researchers are people too. They aren't shielded from the pull of tales. When society fixates on conclusions and upheavals, when models of the cosmos waver, when established truths face scrutiny, that vibe seeps into how experts analyze their findings, which ideas they deem viable, which quirks warrant deeper probe rather than brush off. Research isn't some detached, flawless mechanism apart from our mental wiring. It's a pursuit shaped by folks carrying personal slants and storytelling urges. Those urges unavoidably shape the outcomes. So those contraction studies, no matter their long-term merit, reshape the backdrop for analysis. They smooth the way for grand notions, for pondering vast cosmic scenarios, for questioning whether the quirks we observe tie into bigger motifs. They offer no proof regarding Atlas, but they alter the context in which Atlas gets examined. And at times, that context weighs as heavily as the facts. Yet let's pivot from universal endpoints to nearer-term issues. As stargazers argue over the cosmos's doom, a more mundane yet equally troubling development unfolds in our skyward domain. Spacecraft are plummeting routinely, soundlessly, and their fiery downfall could be concealing key details. Part 9. Starlink's silent shower of flames. Each day, overhead someplace, a spacecraft expires. Not figuratively, actually. Alloys, chips, and photovoltaic arrays scorching to scorching temperatures as they plunge into our air layer, eroding, fragmenting, cascading as tiny particles or now and then bigger chunks that endure to strike ground. A recent tally by a Smithsonian space expert puts it at 1 or 2 Starlink craft incinerating or tumbling earthward every day. Not every month, daily. That equates to hundreds from one vast array disintegrating annually as they drop. The cause boils down to basic mechanics. Low-altitude orbits aren't vacant. Lingering air persists even hundreds of kilometers up, sufficient to generate slight friction on orbiting gear. Gradually, that friction decelerates the craft, dropping their paths, until they venture into thicker air and can no longer hold elevation. Decay in orbit is unavoidable. Any launched satellite will drop eventually without ongoing propulsion to sustain position. For compact craft lacking ample propellant, service life may span just a handful of years before drag dooms them to their last plunge. Starlink, SpaceX's sprawling array aimed at worldwide web access, deploys thousands of satellites in near-Earth paths. The blueprint envisions tens of thousands in total, a web so thick that from anywhere on the planet, several are in view past the skyline. This demands low paths where air resistance bites hard, so replacements are needed often as units fade and combust. Thus, The everyday blaze shower, a constant flow of expiring tech dissolving above us, largely overlooked since single incidents are minor and routine enough to skip headlines. But consider the impact on sky-watching conditions. It introduces mess. Thousands of craft bouncing back sunlight, disrupting scope views, leaving trails on star maps that demand digital cleanup. It boosts erroneous alerts, fleeting blips in celestial scans that prove to be satellites or junk instead of space rocks or icy visitors. It renders the challenging job of monitoring minor bodies across the void even tougher. It becomes even tougher to separate authentic cosmic events from the expanding swarm of human-engineered gadgets crowding the space around our planet. For those attempting to examine entities like Atlas, this issue is crucial during efforts to scrutinize dim features, detect minor shifts in luminosity or path. When verifying if a sighting is legitimate or merely an illusion, the swarm of countless man-made items and sightlines muddies the waters completely. Any enigmatic blip might turn out to be a satellite. Any baffling glimmer could simply be wreckage reflecting sunlight from an odd direction. The baseline interference climbs, raising the challenge of pulling true indicators out of the clutter. There's also a more theoretical angle to explore. Could the surge in satellite operations offer concealment for spotting or concealing other irregularities? If your goal was to monitor Earth without easy detection, or to navigate close Earth orbits while keeping options open for denial, merging with the horde of existing synthetic objects would make strategic sense. Any observatory spotting you might dismiss you as yet another orbiter, additional space trash, or just another element in the escalating mess that experts have learned to ignore. The disguise isn't intentional from you. It's courtesy of our own tech ecosystem, the network of devices we've enveloped ourselves in. This ties into a larger motif of signals amid chaos, how escalating intricacy clouds clear vision. The greater our satellite deployments, the trickier stargazing turns. The heavier the orbital litter builds up, the tougher it gets to differentiate meaningful sightings from trivial ones. We're generating our own mist, encircling ourselves in a tech-induced blur that veils the stars and galaxies we aim to investigate. And any entity seeking to stay concealed, uncertain, or overlooked thrives in that murk. The paradox runs deep. We send up satellites to enhance connectivity and surveillance, providing superior means to probe the cosmos. Yet this very action spoils the setting for those pursuits, rendering faint targets harder to spot, anomalies tougher to follow, and detections more ambiguous, whether they're truly noteworthy or merely tumbling gear glinting in the sun as it disintegrates. Advancement breeds its own hurdles. As our innovations sharpen, they increasingly sabotage one another. And fixes aren't straightforward. Those satellites fulfill needs that society prizes: global web connectivity, climate tracking, vital comms networks, all hinge on the orbital array. Pushing to shrink the fleet equates to sacrificing tools and benefits essential to millions. Thus, the array expands, the mess multiplies, and the viewing conditions keep worsening. That's our current path. And without a dramatic policy overhaul or tech leap, we'll stick to it. This leads to what might be the most baffling part of the Atlas narrative: the quietude, the voids and updates. The impression that bodies meant to disseminate details are withholding them. Why do officials stay so hushed amid strange occurrences? What's driving the selective sharing, the caution or dread? Let's probe the quiet and its potential messages. Part 10. The hush preceding revelation. Quietude conveys data when anticipation builds for updates that never come. When groups that typically issue regular briefs abruptly fall silent. When the lack of declaration stands out more than any issued ones, it sends a message, even a voided one. The reticence surrounding Atlas, the intervals between sightings and bulletins, the meticulous screening of each outward message, all signal intent, though we may not pinpoint it precisely. Orbital organizations function within limits few consider. Each photo shared publicly undergoes scrutiny, adjustment, validation. Every remark on findings must be exact, supportable, resistant to later refutation. This isn't suppression or plot. It's standard prudence from entities whose trust rests on reliability. Should NASA proclaim a find that proves to be gear glitch or flawed reading, the blow to their standing could linger and sting. Hence, they verify, re-verify, hold off until assurance before going public. This breeds a time lag, a pause from detection to declaration, often spanning weeks or months. For standard scans, it scarcely registers. So what if a bulletin on a far-off nebula arrives half a year post-capture? The nebula remains static. But for urgent happenings, for entities traversing THR within our solar system, celestial bodies zip by on timelines spanning mere days or weeks, turning even modest lags into major hurdles. Once space agencies gear up for an official update, the moment in question has typically slipped away, the target has shifted position, and folks are left puzzling over the lack of timely alerts. This trend shows up repeatedly in lately reported incidents. Discoveries of fresh exoplanets via gravitational waves or transit techniques frequently linger for months prior to any public reveal. Captivating radio signals picked up by telescopes undergo thorough internal checks before word reaches beyond the core investigators. Odd snapshots from satellite orbits pass through elaborate review and refinement stages that might stretch over a year prior to going public. Such protocols represent everyday protocols, not limited to Atlas or any single project. Yet, when the sighting hints at the remarkable, this routine drags on differently. When lags impact info that might resolve core queries about humanity's cosmic role, and when the divide between spotting and revealing sparks rumors and rival tales, the usual prudence begins to resemble something more sinister. It resembles intentional suppression, narrative steering, or authorities dictating public access to knowledge and its timing. Herein lie the pitfalls of organizational motivations. Bureaus aim to shape their own tales. They prefer issuing statements on their terms, using their phrasing under their chosen angles. Unauthorized drips harm efforts. Hasty drops risk credibility. Unchecked hype ahead of confirmation spells trouble. From the Bureau's viewpoint, these stances hold water, but to observers, they smack of concealment. They evoke choices hashed out in secret about which details suit everyday audiences. And this perception, true or not, erodes confidence. History offers plenty of cases where bureaus held back or first obscured peculiar results. The iconic Martian visage snapped by the Viking orbiter in 1976 appeared in an early bulletin that highlighted its crafted look, only for subsequent updates to clarify how shadows and clarity skewed views. The famed WOW signal caught by SETI experts in 1977 stayed under wraps in public forums for years, even though it ranked among the most compelling radio catches on record. The fading of Tabby's star, once theorized as evidence of extraterrestrial megastructures, sat in researchers' files long before leaking out via data dumps. In every scenario, valid reasons justified the holdups. Experts sought to eliminate equipment glitches. They aimed to collect extra evidence. They avoided staking unsubstantiated positions. Still, the outcome mirrored each other. Audiences got wind of possibly pivotal sightings well after the fact, via outlets that seemed geared towards spin rather than candid science sharing. Each episode bolstered the notion that establishments were hoarding intel, sorting which inquiries merited broad debate and which stayed confined to elite circles. Now, layer this onto Atlas. The find surfaced in July. Late October has arrived. A smattering of photos have trickled out, mainly depicting dim specks or trails. Bulletins have stressed the mundane comet theory, minimizing oddities, and insisting all aligns with predictions. High-clarity shots from capable gear remain absent. Untouched spectral readings, which outsiders could use to cross-check composition assertions, stay locked away. We're urged to believe that Atlas's examining bodies are disclosing all key details, even as their track record whispers otherwise. This breeds what's termed the quiet interval, the stretch from detection to unveiling where storycrafting unfolds. In that interval, the Bureau steers the plot. They pick what to spotlight and what to tuck into jargon-heavy addendums. They cast the event in wording that molds public takeaways. All this unfolds in unseen huddles and vetting routines. By official rollout, the storyline stands firm, the viewpoint set, the bounds of guesswork drawn. Does this spell intrigue? Not outright scheming cover-ups, but yes, data oversight, tail curation, bureaucratic shielding that nurtures ground for wild theories to thrive. For when audiences sense the incomplete picture, they patch voids with their versions, frequently wilder and less grounded than straightforward truth, if only it flowed freely. Atlas remains the focal point. Various peculiar signals have cropped up. Several space oddities that might or might not link together. Wandering black holes drifting across the galaxy. Gaps in the solar surface messing with our readings. Theories about the universe shifting unpredictably. Spacecraft dropping from orbit like stones. Any one of these might stand alone as separate occurrences. Yet they could also fit into a bigger puzzle we can't grasp yet, thanks to fragmented information. Announcements get held back. Stories get chopped up by official restraint and info-handling tactics. What's clear is that something from a distant star system is currently crossing our own, showing traits that upend our theories, and the groups examining it are playing it safe with disclosures and timing. The quiet could signify zilch, or it could signal a lot. We'll only find out once the chance passes, once the info drops, once we get to examine for ourselves just what Atlas really amounts to. For now, we're stuck with blanks and hunches, gazing at the heavens and pondering what's spotted but kept under wraps. And while we're on the subject of the heavens, let's turn to the schedule ahead. Amid all this oddity playing out, heavenly happenings keep to their timetables dictated by orbits and universal clocks. Such occurrences, these wonders, could serve as diversions or chances to notice more. They might obscure key sights or uncover what stayed concealed. Regardless, they're approaching. Jot them down. The performance is set to start. Part 11. The chill full moon ascends on December 4th. The moon goes by numerous titles, drawn from societies that used its cycles as both almanac and timepiece. This full chill moon climbs on December 4th, 2025. The label comes from early American settlers adopting native customs that tied this moon to winter's fierce start. Icy evenings, hardened earth, the year nearing its gloom before the solstice hints at light's comeback. Full moons carry a deep, instinctive pull. They've swayed human actions since our species began, signaling seasons for foraging, sowing, ceremonies, and festivities. Folks today often claim we've outgrown those pulls, that bulbs and screens have liberated us from the moon's grip. Still, yars buzz more during these phases. Cops spot shifts in incident reports. Research on rest reveals real impacts on our body clocks, even indoors away from the view. Deep down, we remain creatures shaped by those old pulses our forebears adapted to. No matter our denial, this chill moon will shine worldwide, barring clouds, emerging eastward as daylight fades westward, peaking near midnight, casting that eerie pale glow, intense enough for page-turning, yet dim for hues. It's a threshold gleam, straddling light and dark, turning the everyday eerie and exposing the odd. Purely in astro terms, this full moon's nothing special. No supermoon swell, no extra nearness or size or shine. Just the moon doing its loop, bouncing sunbeams back at us once more. Yet in lore, heritage, and mindsets, it counts. Crowds will step out to gaze. Snappers will frame it against hills and urban sprawls. Feeds will overflow with lunar shots, all a bit distinct, all chasing that elusive vibe of lingering beneath it, dwarfed, linked, and timeless in a flash. Now, add a layer of conjecture. Suppose oddities like Atlas sync up, by design or fluke, with times when eyes turn away. A full moon acts like a sky beacon, pulling countless stares skyward. With folks fixed on the moon, other spots escape notice. Scopes aimed lunar or battling its glare, which swamps dimmer targets. Ignore quirks elsewhere in the vault. Essentially, the moon forges a shadow zone, a shared focus that might veil parallel happenings. No claim here of interstellar plots syncing flybys to moon stages. Ridiculous. But it's worth observing that pinpointed human focus leaves openings elsewhere. Illusionists live by it. Slight relies on diversion. Fix eyes on one side, and the other slips by unseen. Train gazes on the moon. Overlook the shadows stirring farther out in the night. This chill moon bears emblematic heft too, shaping how we read goings-on near its rise. Chill evokes wrapping up, stillness, cycles close. December sees retreat, halt to bloom, the globe folding in. Should bizarre happenings pile up near this, if revelations or findings emerge in early December, they'll likely be viewed through that metaphorical filter, focusing on conclusions instead of starts, finality over fresh opportunities. The way the story unfolds depends on the exact timing of these disclosures, regardless of whether the schedule is accidental. And perhaps it truly is accidental. Perhaps the phases of the moon and cosmic travelers bear no relation whatsoever. Perhaps the frosty lunar glow is merely the moon doing its thing, and Atlas is simply transiting by, with any links between them just our brains imposing order on chaos. Yet people are natural mythmakers. We instinctively weave tales from occurrences, links from chance alignments, significance from schedules. As the moon ascends, the interloper glides past, and in their intersection, we craft a tale that resonates with us, even if the cosmos remains indifferent. The key is to pay attention to what catches your eye. When that chilly moon climbs high, when your gaze lifts to the heavens, pause to consider, what other shifts are underway? What celestial bodies are navigating the void? What information is surfacing or staying hidden? What statements are dropping or being postponed? The moon's allure is undeniable, captivating enough to observe, snap pictures of, and honor. Yet resist letting its splendor obscure the rest of the night's display. At times, a dazzling display is nothing more, and at others, it's a distraction from details that might otherwise stand out. On the topic of dazzling displays, the frosty moon serves merely as a prelude. A supermoon looms ahead, larger and more radiant, poised to seize the spotlight in news cycles and online streams alike. Let's explore how this premier lunar spectacle of 2025 could influence our perceptions, and what it might cause us to overlook. Part 12. The Supermoon of 2025. Early November. The term supermoon evokes high drama, reminiscent of superhero tales or apocalyptic films. In truth, it's more understated, yet undeniably striking. A supermoon takes place when the full moon aligns with perigee, the stage in the moon's oval path where it draws nearest to our planet. The moon doesn't circle Earth in a perfect round. Its path forms an ellipse, so at certain points, it's roughly 50,000 kilometers more distant than others. Should fullness strike at perigee, the moon seems around 14% bigger and 30% more luminous compared to its appearance at apogee, the remotest spot. That difference is striking enough to catch the eye if you're tuned in, particularly as the supermoon emerges low on the horizon, where air layers amplify its size via a classic visual trick. The grandest supermoon of 2025 hits in early November, likely the third or fourth, based on pinpointing perigee's peak against the full moon's glow. For everyday stargazers, the fine print hardly matters. The real draw is a string of evenings where the moon commands the darkness, luminous enough to etch deep shadows, gorgeous enough to halt passers-by, and compelling enough to spark a shared cultural vibe beyond pure science. From our angle, that's when intrigue builds. Supermoons spark enormous public involvement. They're entry-level stargazing, no gear needed, just eyes and interest. Media jumps on them. Weather reports flag them. Platforms buzz with images snapped from countless spots and perspectives. Over those nights, countless folks who rarely ponder orbital paths turn into impromptu lunar fans, venturing out to crane their necks, posting their views, joining a widespread cosmic ritual. This is a boon. Whatever draws eyes upward, sparks curiosity about the stars, and ties us to the vastness beyond daily life benefits society as a whole. But it also diverts focus on a grand scale. With all eyes fixed moonward, with scopes overwhelmed by its glare, with chatter flooded by supermoon visuals, subtler happenings can slip by with little fanfare. Atlas reaches its nearest pass to Earth in late October, right ahead of the November supermoon. This alignment ensures that as Atlas traverses its most visible stretch, widespread fascination pivots to the lunar extravaganza. Experts in astronomy will keep tabs on Atlas. Naturally, they're immune to lunar distractions. But for the general public, press attention, and wider discussions on space happenings, the emphasis swings to the easier-to-grasp, more photogenic phenomenon. Atlas fades into the periphery, if it's even highlighted, eclipsed by the supermoon's broad allure. A recurring trend emerges here. Big reveals often drop when eyes are averted. Officials unveil tough measures on late Friday afternoons heading into long weekends. Companies drop grim earnings reports post-trading hours. This isn't always shadowy plotting. It's savvy messaging, selecting moments that soften backlash or give room for the info to sink in, without facing sharp public examination right away. Might a similar approach hold for unusual space occurrences? Could the choice to reveal or withhold info tied to big astronomical happenings be an intentional way to shape how people respond? Possibly. Or perhaps the schedule is purely by chance. Just the outcome of planetary paths and viewing opportunities, unrelated to any plan for sharing news. Yet the impact persists. As the supermoon takes over discussions about the cosmos, oddities such as the Atlas event slip quietly to the sidelines. Inquiries that would echo strongly amid calmer headlines end up whispered or overlooked entirely, overwhelmed by the buzz around the supermoon. And consider the mental side of this. Supermoons hold a peculiar kind of solace. They're reliable, anticipated, woven into the steady cycle of heavenly motions. They serve as a reminder that certain aspects of the cosmos remain steady, that paths around planets obey logical principles, that we can forecast and ready ourselves for such moments with flawless precision. Amid eras of stellar doubt, where tales of alien probes, wandering singularities, and end-of-world cosmic theories ripple through expert talks, the supermoon brings a sense of calm. See, it implies, the cosmos functions as they taught you back in class. The moon circles our planet, as always. Closest and farthest points arrive right on time. Not all is weird out there. This sense of security, this nod to the known, could be precisely the mental boost folks require, or it might stop them from confronting truly bizarre shifts. When comfort comes calling, when a dazzling display hands you a simple thing to fixate on, it's easy to embrace it and sideline the tougher, more disquieting puzzles hiding beyond the glow. The supermoon dazzles, yet a lure can ensnare. It's a distraction that fixes your gaze one way while leaving other paths uncharted. So as the supermoon climbs in November, as that swollen, glowing orb commands the heavens, make sure to glance elsewhere too. Spot what other sights appear. Wonder what information is dropping or being kept under wraps. Observe if updates arrive amid the supermoon hype or get time to follow once the show fades. The moon merits your focus, but it ought not claim it all. The night sky stretches wider than its most radiant feature, and at times, the key happenings unfold in those shadowy zones we'd prefer to skip. On that note of trails cutting through the night, the supermoon isn't the sole stellar performance lined up for the near future. Streaks of shooting stars are on the way. Yearly displays that streak the firmament with flames, each with their own knack for seizing eyes, and maybe masking what deserves our notice. Now let's shift to the southern Taurids and the scene when the heavens light up with luminous paths. Part 13. Flames across the heavens. The southern Taurids. Each year come early November, our planet's path guides us into a trail of remnants dropped by Comet Encke, a brief-duration comet that loops near the Sun every 3 years. Those remnants create a flow of fragments aligned with the comet's route. As Earth crosses that flow, the bits crash into our air layer at roughly 30 kilometers per second. The drag ignites them to a glow. They burn up in vivid trails. We label it a meteor display, in particular the southern Taurids, so called since the streaks seem to burst from the Taurus star group. The southern Taurids don't rank as the flashiest meteor event. Top counts usually hit just 5 to 10 per hour, tame beside bursts like the Perseids or Geminids, which can unleash scores or even hundreds in an hour at their height. Still, the Taurids earn praise from stargazers for sparking fireballs, exceptionally vivid streaks that can eclipse the top stars for a moment, sometimes trailing lasting wisps of shimmering charged vapor that hang around seconds past the streak's end. The event runs from late September to late November, with strongest action often in early November, syncing up with that supermoon phase we covered. Thus, in the very stretch when the moon shines extra vivid and eyes turn upward, the firmament also gets dotted with meteors. Everyday pyrotechnics that amp up the drama and reinforce the feeling of abundant action overhead. Viewed one way, this alignment is mere happenstance. Our world's path stays set. Comet Encke's particle trail sits fixed. The moon's nearest approach falls as it does. These are separate forces guided by pull of gravity, indifferent to our watching or what we make of it. The concurrent timing simply shows the universe humming on several fronts at once. Seen another way, the convergence generates clutter. When you're scanning for particular items in the void, hunting irregularities or odd paths, a heaven brimming with observing a flurry of meteors makes the job tougher. Each flash in the sky needs careful classification. Could it be a Taurid? Might it be a satellite? Perhaps space junk? Or something entirely different? As more everyday cosmic events unfold, sorting the real signals from the clutter gets increasingly challenging, distinguishing true oddities from routine occurrences. Now, here's a thought-provoking idea to ponder. Might bits of interstellar visitors get mistaken for meteors? Comet Atlas is venting gases, releasing particles as it journeys through our solar system. This ejected stuff creates a trail, a swarm of debris trailing the comet's path. Suppose Earth crosses that particle flow, and chunks of alien material plunge into our atmosphere. Would we spot them as separate from the predictable yearly meteor displays? Or would we chalk them up to the Taurids, mere remnants from Comet Encke, and never dig deeper? The makeup ought to give it away. By analyzing meteor spectra, experts can pinpoint the elements, and interstellar stuff should display unique chemical markers unlike those in solar system comets. But that relies on capturing the data from that exact streak, on getting the reading in those fleeting moments of visibility, on spotting anything odd enough to merit close scrutiny. For most fireballs, we catch a glimpse, snap a pic perhaps, and that's it. In-depth spectral studies only target the standout or heavily documented ones. This leads to a masking dynamic. Intense meteor periods offer camouflage, a baseline of normal activity that could obscure surprises. If someone aimed to monitor Earth without easy detection, if they were dropping material into our air, sinking it with a big meteor shower would make perfect strategic sense. Your cast-offs mingle with the anticipated junk. Your traces vanish amid the usual buzz, and skywatchers, primed for the familiar, label it all as standard fare without a second glance. Pure conjecture, of course. No signs indicate Atlas debris is hitting our atmosphere. Nothing suggests weird stuff lurks within the Taurids. Yet the setup allows for it. The conceptual gap where mix-ups could slip through. And highlighting that gap matters, as it tempers our certainty in what we think we're seeing. Meteor showers also pull gazes skyward. Much like a supermoon or any stellar display, they concentrate focus in particular spots at set times. Folks stepping out to hunt Taurid fireballs tune into the heavens more than usual. They're scanning, gesturing, snapping shots, but zeroed in on the shooting stars, the anticipated spectacle. Other sky travelers might appear as overlooked extras against the main event. The Taurids hold some lore among astronomers too. Certain studies propose that the Taurid swarm, the wide debris band linked to Comet Encke, could harbor bigger pieces, kilometer-scale boulders that threaten Earth with strikes. These ideas spark debate and lack broad support, but they infuse a subtle edge of peril into an otherwise stunning yearly ritual. Gazing at Taurid streaks means admiring harmless specks. Still, a nagging doubt lingers. Is a heftier threat lurking in that same flow, barreling toward us? Atlas doesn't tie into the Taurid group at all. Its roots are purely extrasolar, unconnected to Comet Encke. But the mental link, the tie between overhead wonders and risks, shapes a mindset where strange sights get viewed as perils. The Taurids underscore space's dangers. Atlas, zipping in from beyond with quirky traits, fits neatly into that risk box, despite zero crash worries. The stories overlap not from shared facts, but from stirring alike instincts. Thus, as the southern Taurids crest in early November, with the heavens alive with trails and blasts, stay alert beyond just the meteors. Watch for reports of odd movers that get brushed off. Wonder if the blending of patterns is mere chance or cleverly timed. The Taurids deserve your gaze. They're a true cosmic marvel, a nudge that our world sits within a lively cosmos where stuff never stops shifting. Yet avoid letting the routine display obscure surprise acts elsewhere above. And the Taurids are merely the opener. A string of meteor barges lies ahead. A barrage of starry pyrotechnics set to illuminate the night through November and into December. Let's explore how this unfolds. The grouping of celestial events could be influencing our perceptions, both revealing wonders and concealing subtleties in the gaps amid those fiery trails. Part 14. A flurry of the Leonids, Geminids, and Ursids. Late 2025 promises a bustling heavens, filled not only with the Atlas comet, but also with supermoons and solar coronal ejections, alongside a steady lineup of meteor displays. These three prominent spectacles unfold in rapid sequence, as if orchestrated by the cosmos for maximum impact. The Leonids peak on November 17th and 18th, stemming from remnants of Comet Tempel-Tuttle and seeming to emanate from the constellation Leo. Renowned for sporadic bursts into meteor storms, where thousands of shooting stars light up the night at rates of thousands per hour, triggered only in years when our planet crosses especially thick parts of the comet's trail. 2025 won't deliver such drama. Instead, expect a tame showing of perhaps 10 to 15 meteors hourly at their height, best viewed in the early morning when Leo climbs highest. Following suit, the Geminids ignite on December 13th and 14th, often hailed as the year's steadiest and most dazzling shower. Uniquely, they don't hail from a comet but from asteroid 3200 Phaeton, possibly a depleted comet that's lost its icy layers, leaving just the stony nucleus behind. At full strength, the Geminids can unleash up to 120 meteors per hour, featuring vivid, rainbow-hued flashes observable from any earthly vantage, assuming clear skies. This dependable extravaganza often makes headlines and lures stargazers outdoors despite the wintry chill. Wrapping up the trio, the Ursids streak across December 21st and 22nd, originating in the constellation Ursa Minor from debris of Comet Tuttle. Usually subdued, with rates of just 5 to 10 per hour, they contend with bad luck in timing, cresting near the northern hemisphere's winter solstice, offering extended darkness but frequently marred by foul weather. They serve as a subdued finale to the annual meteor roster, paling beside the Geminids, yet a consistent December highlight. Spanning these three key showers over 5 weeks, they coincide with Atlas's trek through the solar system's core, a supermoon's glow, and heightened solar flares from that coronal void. If crafting an era of peak astronomical frenzy, utmost heavenly drama, and countless incentives for eyes and telescopes to tilt skyward, this lineup would be hard to top. The cosmos has gifted us an enchanting fall transitioning to early winter, a stretch of stellar spectacles that will captivate experts and backyard enthusiasts alike for extended periods. Yet this clustering sparks intriguing dilemmas. As meteor activity intensifies and the firmament fills with anticipated wonders, the viewing conditions grow intricate. Unidentified items must be sifted from the familiar clutter. Odd sightings vie for focus against these captivating, fully understood occurrences. Meteors dazzle, merit observation, and hold their own scientific merit. Still, from the angle of monitoring extras, they introduce interference, a constant hum that rarer signals must surpass to stand out. Might interstellar debris, hazy veils trailing Atlas's path, or ejected bits from its solar system John align with these routine showers? Could extrasolar matter be plunging into our atmosphere at this moment, incinerating beside Leonid or Geminid fragments, overlooked or wrongly labeled simply because we anticipate, and thus perceive, meteors in these slots? Detailed chemical analysis would expose any differences, provided we scrutinize intently. However, we don't spectrum every fireball or dissect each trail. Most go by on mere eyesight, maybe snapped in photos, and nothing more. Just a sliver receive the rigorous study needed to uncover atypical makeup. Thus, if alien stuff blends with local rubble, or quirky specks lurk within the norm, spotting them seems unlikely without something glaringly offbeat, wildly aberrant, or utterly indefinable. Factor in the psychological side too. Once stellar happenings embed in our timetables, anticipated, embraced, and routine, they fade into the everyday tapestry. Geminids grace December annually, Leonids November without fail. These stand as certainties, as routine as solstices. No enigmas here, no oddities, just the steady pulse of our orbits sweeping through ancient comet and asteroid leavings. Such familiarity proves handy, enabling forecasts and setups for viewings, public engagements, and turning wild space antics into graspable rhythms. But all this leads to overlooked areas. Once something becomes routine, we cease to challenge it. We lose the ability to view it anew. We sort, categorize, and proceed without pause. And if a truly odd element lurks inside that familiar routine, we could overlook it completely, having conditioned ourselves to skim over occurrences we believe we grasp. The grouping of these meteor displays near Atlas's trajectory might simply be chance. The rules of orbital dynamics ignore our stories. Our planet's route through diverse particle trails follows gravity's dictates, unaffected by whatever cosmic wanderers happen to cross paths at the same moment. No basis exists to assume the schedule is linked or significant. Yet, timing shapes the backdrop. When big headlines emerge amid diversions, they draw minimal scrutiny. When key shifts unfold as crowds fixate on other matters, they risk being downplayed or ignored. That dynamic could extend to the stars. Amid a sky packed with anticipated displays, like meteor barges, supermoons, and routine celestial shows, oddities might slip by with far less examination than in calmer skies. This doesn't demand intent. No plot or orchestration is needed. It's merely the outcome of limited focus, of finite nighttime hours, limited scopes aimed skyward, and constrained bandwidth for sifting data. In times of abundance, not all elements receive equal spotlight. Decisions shape what's highlighted, funds direct efforts, and certain items, possibly crucial ones, drop to the back burner just because they vie with flashier or more pressing spectacles. Thus, as the Leonids flash, the Geminids flare, and the Ursids wrap up the season, keep in mind you're viewing a filtered spectacle, not shaped by any person's design, but filtered by the bounds of perception and vigilance. The visible draws your gaze, the most vivid, the most apparent, the most predictable. The unseen could hold greater weight, tucked into shadowy gaps amid the trails, gliding across the heavens as your attention follows the bursts. This loops us back to the core puzzle we've danced around in this probe. Do all these stellar happenings, these moons, meteors, voids, and quirks, amount to mere scheduling, sheer luck, the cosmos simply bustling in disjointed parallel? Or does a broader design lurk? Some arrangement we overlook because proximity blurs our view. Let's pull away and scrutinize the timeline outright, pondering if we're amid a ticking toward an unknown climax. Part 15. Timeline, or timer. Survey the pieces we've gathered. An interstellar visitor with peculiar traits traversing our system. A wandering black hole roaming the Milky Way. A vast solar void scrambling observations. Research hinting the cosmos could collapse instead of stretching eternally. Orbiters tumbling earthward each day, muddying the view. A supermoon seizing the spotlight. 3 prominent meteor events jammed into a 5-week span. The cold moon ascending, laden with its emblematic aura of finales and resolution. Viewed alone, each makes sense. Ordinary, anticipated, or at worst, unsurprising. The cosmos sprawls vast and active. Oddities arise often. Spotting several curiosities aligning shouldn't shock. The pool of possibilities is immense. Cosmic curios loom in endless supply. Some piling up is bound to occur. Yet the piling feels insistent to brains wired for designs. These aren't isolated blips strewn over months. They're bunched, funneled into a tight slot from late October to December 2025. And each, in its fashion, hampers either our sharp sighting or our watchful focus. The solar void hampers gear. The supermoon hooks eyes. The meteor flows generate static. The orbiters clutter the feed. Atlas navigates the midst, elusive and irregular. Spotted, yet vague. Probed, yet unresolved. So consider 3 lenses for decoding this display. 3 paths to grasp what's unfolding. 1. Sheer chance. The cosmos shrugs at our watching or spin. These are standalone occurrences that overlap by random whim. Clumps emerge from chaos. Alignments arise. Implying intent here is just apophenia, our itch to forge links from random static. This view is the most secure. It demands no leaps, no wild theories. It's likely accurate. 2. Story shielding. Not scheming, not plotting, but an inherent setup where real oddities gain cover by timing with high clutter and interruptions abound. If Atlas stands out as an oddity, something primed to draw sharp attention in calmer times, then slipping through amid a flurry of wonders offers built-in shielding. This isn't due to any orchestrated scheme, but rather the chaotic watchfulness that scatters focus, complicates verification, and invites brushing off or postponing for future review. Viewed this way, the schedule needn't be intentional to carry weight. The outcome persists irrespective of purpose. The third perspective, celestial alignment. This one's the most conjectural, the toughest to bolster, yet it merits exploration. Suppose these occurrences tie together in ways beyond our grasp. Imagine Atlas fitting into a grander scheme, some force or dynamic rippling across various cosmic layers all at once. We've treated them as isolated factors, concurrent happenings without overlap. But what if they're intertwined? What if wandering black holes, wandering interstellar bodies, sun flares, and even meteor trails connect via unseen forces? In this view, it's not mere chance we're spotting. It's a design, its rationale obscured by our missing conceptual tools to decipher it. Each viewpoint carries merits and flaws. The chance angle is straightforward, yet risks overlooking real oddities. The shielding idea credits systemic influences sans motive, though it could inflate random static. The alignment notion sparks the mind, but calls for proof that's absent and likely elusive. Picking among them demands balancing not only evidence, but deeper assumptions on reality's nature. Does it hide designs, or is happenstance eternally mere happenstance? Undeniable is that the star-studded lineup for late 2025 packs an extraordinary array of spectacles. Be it haphazard bounty or purposeful depth, be it timing that boosts or blocks insight, be it routine cosmic churn or a hint of greater import. These puzzles defy firm resolution from current intel. We're stuck in ambiguity, eyes on the heavens, monitoring the timetable, pondering if it's merely ticking away or edging toward revelation. And one last uneasy musing. Perhaps the inquiry is the essence. Perhaps the key isn't if Atlas springs from nature or artifice, if its arrival's accidental or arranged, if we're beholding marvels or merely twisting the mundane via our biases. Perhaps the crux lies in posing such queries, in gazing skyward, in wrestling doubt instead of fleeing to absolutes. The tale spinning around Atlas, the meaning we weave for its essence and implications. That tale mirrors our inner world as much as the thing itself. It exposes our dance with vagueness. Do we leap to verdicts or linger in ignorance? Do we lean on authorities or probe them? Are we game for jarring ideas? Or do we crave a cosmos that hews to the familiar for our ease? So, tilt your gaze upward. Witness the icy lunar ascent. Tally the shooting stars as they dash. Mark the supermoon's glow and the shadows encircling it. Follow Atlas on its solar jaunt before it fades into the starry expanse. Yet turn inward too. Spot what convictions you crave and their roots. Spot what unease stirs you and what it shields from view. Spot the tales you spin about celestial shifts and see them as tales, our inventions draped over happenings that stand apart from our takes. The almanac marches on. The timer, should one exist, advances on rhythms beyond our sway. Occurrences will play out. Findings will surface or stay buried. Inquiries will resolve or morph into fresh ones. And we'll persist, observing, musing, forging tales. It's our way amid enigmas. Who scripted this roster? The bunching of stellar happenings over these precise months? Did a scriptwriter even exist? Or does that probe miss the mark, foisting creators onto flows that just persist? The cosmos doesn't author. It doesn't scheme. It evolves by rules we half comprehend, yielding designs that at times seem crafted, though they may stem from intricate cycles over immense epochs. Or perhaps, just perhaps, certain designs bear craft. Certain rhythms pulse with design. Certain skycrossers bear purpose, not just velocity. We lack the answers. We can't claim them. Not now. Not via today's tools of sight and tally. But we can stay receptive to options, steering clear of dogmatic traps. Whether you accept the idea that Atlas is merely a comet, that could well be accurate. Yet you risk overlooking humanity's greatest breakthrough, opting instead for ease rather than unease, assurance over ambiguity, the familiar against the truly otherworldly. On the other hand, if you suspect Atlas represents something greater, you could be onto something. Still, you might just be spotting connections in chaos, imposing order on chance, weaving complex explanations for evidence that yields to straightforward accounts. True intellectual integrity lies in skepticism paired with vigilance. Skepticism about our capacity to reach firm judgments. Vigilance toward the revelations from the cosmos, no matter how unsettling or unclear. The heavens remain unmoved by our convictions. They simply exist. And we, fleeting witnesses equipped with flawed tools and skewed perspectives, strive to decipher their signals etched in radiance, force, and the paths of celestial bodies spanning inconceivable expanses. Gaze skyward, yet ponder who might have scripted the events, if such a creator exists. Consider what escapes your notice as you focus on the obvious. Reflect on whether the account you've embraced is your own choice or an imposed one. The universe sprawls immense, bizarre, and aloof from our tales. But as narrative-driven beings, the narratives we craft about the stars mold our grasp of our own essence. So craft those narratives with precision. Scrutinize them intensely, and bear in mind that the most authentic response to the enigmas of the heavens may, for the present, boil down to this: we remain ignorant, yet we observe. That very observation marks the dawn of insight,